This is part two of chapter 3.1, measures of central tendency. So last time we looked at arithmetic mean. Now we're going to take a look at the median. The median is another way to kind of describe data, looking at what we call the middle of the data set. That's what we call central tendency. Let's double check this here. And so there it is. The median of variables, the value that lies in the middle of all the data. So you list all the data. You've done this before. Here are the steps to use. Arrange the data in order, determine the number of observations, and then determine the middle of the data set. And sometimes it depends if it's odd or even number of data points. You have different ways to do it, which is, again, if you're looking at an even number of data points, it's harder to, you have to actually then add the two data points and divide by 2, which we'll take a look at. And so let's take a look at an example here. Looking at there, the median again, here are the steps. And again, we're going to use technology, but I do want, you need to conceptually understand what the median is. And so again, looking at the median conceptually, here's all this data here, and there are 10 data points here. So looking at the middle of the data, you end up going, there's 1, 2, 3, 4, 5. And then there's the other 5, so the middle is going to be right there. That's where the median would be. And so in this case, your median is in the middle of that. How do you find the middle of two numbers? What you do is you add them up and divide by 2. That's how you find the middle of two numbers, or really finding the average of the two numbers. That's 159 divided by 2. So that would be 59. Sorry, this would be 79.5 would be your median there. And so we were going to do this also. I want to show you using technology to find the median. Again, the median is just another way to measure the center. And so here's that data in for the second example. You go back to summary stats, columns, and looking at example 2, and then you see there is a median choice somewhere there. There it is. Compute, and then you get the median 217 using StatCrunch there. And so that's how you would do that. You need to play the video again, do that again here. The median is 217, and this was again using StatCrunch to get the medians, which we'll be doing that. Okay, so the median, again, something you've done by hand before, know what it means. It's the middle value. You have some extra homework on that to practice that. Now we have another concept here called resistant. A numerical summary of a data set to be resistant. And so what we're talking about here is when sometimes data has extreme values, like all these are kind of close together, there's no outliers, like numbers really far away from the other ones. And so for example, on this data here, if you had another data point, if there was another student and they scored 20, it'd be some outlier, and that would be what we call an extreme value, very large or very small relative to the other one. And so what happens is when we look at the histograms of data, we can tell through the skewness if they have outliers or not. And then we can then determine, like here it says skewed left here. In that case, you have all the data. The median will still be in the middle, but the mean will have a smaller value. It would be less than the median when it's skewed to the left. If the mean and the median if the distribution for the data is symmetric, the way it is here, when you get that normal curve or the bell shape, the mean and median are going to be about equal to each other. And if you get data that's skewed to the right, you'll see that the median again is towards the middle of the values, and the mean is now greater than the median. So what we say is it's resistant to extreme values if it does not affect its value substantially. So what we know is the median is resistant. Something you need to make a note of. The median, and this is a classic test question. Median is resistant because it doesn't. The median is not affected by extreme values. The mean is not resistant. Okay, and so you can answer this question here: which measure, the mean or the median, is resistant? I already told you it's the median. If a distribution is skewed right, what is the relationship between the mean and median? Here's skewed right here. you will then see that the mean is greater than the median when it's skewed right. It follows the tail. And if you can remember the visual, um, I always say the mean chases the tail of the distribution. It's like a dog, and it's chasing the tail, chasing its own tail. So the mean goes towards that. That's how I know it's bigger than the median. The median always kind of stays in the middle. The last thing that we have in this class, for central tendency, is the mode, and that's usually the one that people remember the most. They remember this because the mode means the most frequent. So that's an easy one to remember. And if no observation occurs more than once, we say the data has no mode. And so usually that's the easy one for students to remember how to calculate, because you just look at to see which one comes up the most. You see here the mode is equal to 0 from this data set. And there's some other words that we have. Bimodal, which means 2 modes. And the other one is multimodal, which is again more than 2 modes. So you want to keep that in mind there. And this last part here, list the conditions for determining when to use the mean, the median, or the mode. You're going to go ahead and fill in those spots using the PowerPoint here. Here are the conditions here, when to use it. So that's what when to use the mean, the median, and the mode right here. You can see mean is used when the data is quantitative and you have symmetric data. And again, these are classic test questions here, me showing that you understand these concepts. Use median when the data is skewed left or right here, and then use the mode when the data is qualitative, or when we're interested in what happens the most. That's when you use that. That's it for part 2.